We are starting a new topic today, that is Introduction to Power Electronics. In this subject, we will discuss mainly about application, devices, and concepts. So I will just go to the slide. Right. So first of all, we have to understand what is power electronics. What is the definition of power electronics? So power electronics is the application of solid-state electronics for control and conversion of electrical power. That means control and conversion of electrical power. So we will elaborate a little more, and I will just tell you, it is a branch of electrical and electronic engineering. Everybody has to study about it. So that is why we have taken up this particular topic that focuses on conversion and controlling of electrical power using semiconductor devices. Semiconductor devices we use, in the circuit or this thing we will use. So we will be using semiconductor devices. This particular subject, it will handle from high power to low power or low power to high power. We'll discuss everything. That means we study everything from low power to high power. Low power means we use in electronics, and high power we use in electrical subject. High power means what? Like power generation, distribution, there we use high power. That is, we can also say that from few milliwatts to several megawatts. Right? Okay. Now just come down below. What are the four main functions we study in this power electronics? First is rectification, that is conversion of AC to DC. That is converting alternating current to direct current, like in mobile phone chargers and all, your battery is charged. So we convert AC, that is line voltage, to DC. Second is inversion, nothing but DC to AC. From battery we generate alternating current to run our electronic or electrical home appliances. Right? Okay. Then the third comes DC to DC. Correct? Now, what is this DC to DC? It is called as, like in SMPS, you must have heard in power electronics, we study about switch mode power supply. At SMPS, the DC is converted to DC. It is, we call it as a chopper, right? It is converted to DC. So that is, the SMPS is an important part of the subject. You do that also. That is the conversion of DC to DC. Then I said switching and control. Switching and control, again, the same thing. Switch mode power supply using semiconductor devices. We convert switching. Okay, we do switching. Right. Okay. We will go to the next topic. Next slide. What are the basic power conversion? Again, the same thing. AC to DC, that is, we call it as a rectification. DC to AC, we call it as a inverter. Right. And DC to AC, DC to DC, we call it as a chopper. And AC to DC, cycloconverter, but we don't, AC to AC, we don't usually study more. The four, this thing is AC to DC, DC to AC, and DC to DC. Correct? These three are very important for us. You can see in the figure, battery, diode, and that power supply regulator and bridge has been shown. We'll study a little further. We'll go to the next slide. Now, what is rectification? First one. What is the definition of rectification? What we do in rectification? Convert AC to DC. In this, we'll do some practical related to this. That is half a rectifier. We'll construct half a rectifier, full wave rectifier, and bridge rectifier. Half a means only half of the cycle. That is AC cycle. Half of the cycle is rectified by using only one diode. Whereas full wave rectifier using a tapping transformer. That is, you have three terminals to the secondary side of the transformer that we have already discussed in the transformer section. So here we use two diodes. And bridge rectifier is nothing but it's a combination of four diodes. So mostly you will find four diode combination, we call it as a bridge rectifier. Okay. So definition of rectifier. So we understood, I hope. Right. We'll go to the next slide. Next is inverter, which converts DC to DC, DC to AC. We have inverters in our homes, UPS and inverter. This is very important part in our home nowadays because our devices, some of the devices, they work on AC. So we have to compulsory convert it to DC to AC. So will he use a power supply or a system or a power electronic device, which will convert DC to AC. So it is used in solar power system, uninterrupted power supply, that is, we call it as a UPS. So there it is used. One small diagram I have shown you, the block diagram here, how you can make a small UPS or simple UPS circuit. Okay. So next very important part is power electronic devices. In these devices, what are the different type of devices what we use to conversion purpose? Like diode is the one device, very common device, which converts AC to DC. That is rectification, we call it as. We use thyristor, SCR, then diarch, triarchs. These are a lot of things are there. What we study more. We are not going into detail, but I'm just giving you a little idea. You should have, before going into the industry, you should have this: what is diode, what is thyristor, what is what is MOSFET, what are IGBTs. MOSFET, IGBT, again, we have already discussed in other class. Now we will do, and I have shown you one more circuit here, that is full wave regulator power supply using voltage regulator IC. This we will do it practically and we will discuss about this. Okay. Two more topics we'll discuss more about this thing. That is, one is solar power system. So power electronics, we will study more about solar power system and electric vehicles, because these two topics are the hot topics. You should all the students should have idea about these two things. So in solar system, we can go into it, but I will just give you a little idea how power electronics is related to solar system and electric vehicles. So hybrid power, there are three types of systems: hybrid solar system, off-grid and on-grid. Hybrid means both off-grid and on-grid. We take it together, we call it as a hybrid. That means batteries are used, and also the production, that is whatever the energy we have generated, we can give it to the Department of Electricity, or we can give it to others through the lines which are coming from outside. Off-grid is nothing but only batteries, no outside connection. On-grid, only no batteries, only you will give connection to the outside lines, right? To the boards or electric department, this thing will be there, this thing. So you have to understand these three things, 3 points. In that, you have to understand the battery charger. We call it as charging controller. So I've given a small circuit. You can see, you can do this circuit by using solar panel, how we can ultimately charge the battery with the solar system. That is, we say off-grid or hybrid, in hybrid way. So here we can discuss more, but this small circuit which I have given, we will try to do it in the practical session. Okay. Now we'll discuss about electric vehicle a little. What is electric vehicle? Again, here also we use very important part, that is electric motor driver, controller, and charger, and batteries. These are all your power electronics or power electrical related subject. Okay, so we will study about this. In that, motor controller is very important part. Motor which controls the motor or which drives the motor, and the wheels move around. So that is also control power electronics. Motor drivers are very important part, where we use IGBTs and MOSFETs. Charger, which charges the battery. AC to DC is to be converted, or DC to DC is to be converted. There also we use power electronics more. And battery, of course, the energy has to be stored in the battery. So we will study about the batteries. In the coming class, we'll do some practical related to power electronics.